and I'm very happy and very honored to have like the company. I'm now on holidays. This is my holidays. I'm now on holidays from working with these folks with privacy, scaling, explorations. This is big applause for privacy, scaling, explorations. This is Mo from Privacy Scaling Operation. A big applause for him. Ecosystem development, and there is a lot of speakers coming today. I don't know, like 8 or something, 6, 8.
Yeah. So everyone, Mo from PSE. I've met a number of you before, and there's also I can see a number of people from the PSE in the audience. So shout out to them. So just to firstly, thank you for inviting us to come down and talk about the work that we're doing. To give everyone just like a quick overview of what to expect, there's a residency that's happening that we're doing, and there's a number of projects from the PSE and also within that residency. So what we'll be doing is that we're going to be coming over and we'll be kind of talking a bit about that. So Althea, who is also someone that works within the organization, will be coming down to give an intro. They're running a tiny bit late, so you're going to have to make do with me until we're here. But I can, kind of give you guys an overview of what to expect, and answer any questions while we're waiting for them to come down. So before I go ahead, anyone have any questions? No? Okay, cool. So so we're going to be talking about a couple of different things. We'll be talking about the kind of the residency that Althea is running. We're also going to be going over a number of different projects that we've been working on. So we'll have key speakers from various different research projects, development projects, and also ones within that residency, covering a whole range of things from okay. Oh, because you're recording this, right? Sweet. Let me just clip this. Yeah, Althea's definitely going to speak. She's just unfortunately not here yet. So basically there'll be projects ranging from a bunch of different things, from research that we're doing on, for example, decentralized ID, to protocol and level work that we're doing, and also kind of like some of the education initiatives that we're running. So one thing that we're also quite interested in doing is opening up the pipeline for people becoming ZK engineers and researchers. So we have really quite a broad spectrum of different things that we'll be covering during this kind of presentation. Now, with that said, I don't really have much more to add until everyone else is here. But yeah.
Okay, I'm going to go downstairs and see if I can prepare the badges.
Okay, cool. Yeah. By the way, we're not normally late, so this is atypical for us. But you got me. How's everyone? So is everyone here part of the Invisible Gardens residency then? Is everyone here basically like a developer or a hacker, or is there like a mixture of mentors as well? Like, who's kind of what's the distribution here? So if everyone's like, okay, who here is a builder? Who's here to hack away? Okay, cool. And who's here as like a partner or a mentor? Okay, sweet. So I see there's a good mix. I think everyone here will probably get some really interesting takeaways from the stuff that we're doing. I hope actually at the end of this presentation and kind of overview of projects, what ends up happening is that we can get people kind of working on some of the projects that we're working with, so some collaborations, and maybe we can kick something off from there. Okay, so I think we'll just have to wait until everyone else is here.
I think you were talking about some program.
Yeah. So I actually could talk about one of the initiatives that we're running, but I've got that scheduled until at the end of basically at the end of the current agenda. But saying that, I could start, maybe kind of go first. Maybe I'll kick this off. Why not? Yeah. Okay, so does anyone know how we're going to do this? Just give me a moment. Oh, hey. I just want to kick off my my presentation first.
I've just been chilling downstairs waiting for somebody to tell me what to do.
Oh, okay, cool.
We can get started.
Yeah, we can go ahead and get started, yeah. So I think we'll stick to the agenda, right? Do you want to go ahead and...
So that would mean I go first.
Yeah, yeah.
Let's get this over with.
Actually, I don't think...
Let's see. I have
no, you
that
can-
one, two, either.
Don't even get on that.
Wi-Fi situation.
Well, I think I'm going to pass it here.
Right. Actually, I might have it on paper.
So I think the password here is this.
Okay. Let me see if I have a PDF, because then I just don't have to read that.
Yeah.
Do I have a mouse? Hello? Computer? Do you want to function or no? That was the problem. Okay.
Oh yeah, because this one things out. Yeah.
Momentarily.
Yeah.
So I'll just do this.
Yeah, do you need
Got
to-
it.
Sweet.
Yes?
I'm good now. We were struggling for a second.
Yeah, I'm gonna kind of
Oh,
move
yeah,
over
sorry.
there. Let's grab that. That's okay. Go ahead. Go ahead. Go ahead. A. Oh. Oh. A.
Hey. What is this? This is like a clip-on situation? Okay. We good? I say as if I am not the reason for the delay. Okay. Is everyone ready? Hello. Sorry, I'm late. But thank you all for being here. I'm just going to introduce the residency a little bit. Everybody that's going to present from here on out is with the deshidification technology residency. So people are building lots of different things, but by our own interpretation, they all sort of fit under this category. So in order to understand kind of what we mean by deshidification, I think it's useful to start with the concept of enshidification, which was kind of the anti-inspiration for the whole thing. So this was a term coined by Cory Doctorow to describe kind of what he described as an inevitable process of technology sort of going through these phases of first being good to their users, then abusing their users to help out their business customers. Basically, their users are not their customers, and so they kind of screw over the users to help their real customers. And then finally, they abuse those customers to kind of claim all of that value for themselves. And that's what he calls the process of enshidification. So it's basically like treating the users as, sometimes people say if it's free, you're the product, but it's sort of like more sinister than that sometimes. It's like you're not even a product, like you're not even that special. You're something like to harvest resources from. And so humans have very little like importance or agency in a lot of these technologies. They're just sort of, they want to get you here and get you, addicted or to the point where you need something bad enough that even if they make it worse and worse and worse, you will stay so that they can continue to kind of extract from you. So what's the opposite of that? This is my best concise definition of this. Treating the experiences of living beings, whether that's people or animals or dandelions, as valuable in themselves and not just a means to an end, not something to extract real value from, but like where the value exists in the actual experience of being a person and wanting to deliver that and improve that rather than take everything that you can from it. So what do deshitifiers do that kind of brings us to that point or on that trajectory? Viewing users as subjects rather than objects. So again, it's like people who are having experiences and making choices and sort of deserve to make choices and to build their own worlds and to make the world in whatever image they desire, whatever works for them, rather than sort of components in some system that serves something other than themselves. Thinking about technology as a creative medium, like not purely technical, but also something that can be expressive and connecting and that can help enhance the human experience. It's not just a machine. And like starting from the point of what do we actually want to create, what kind of experiences do we want to enable, like what is our ideal end goal, and not just trying to copy the way that things like should be done or how things have been done, but accepting that like having totally new goals probably means having to also take new approaches and accept a certain amount of unknowability in what that's going to look like, and thinking more like creatively and critically about how we can get where we want to go. Building systems that actively resist capture and extraction and manipulation, which are sort of the three pillars of modern technology at this point. It's like trying to get people stuck in an environment. It's trying to get as much out of the people who are using your technology as you can, and like regardless of how they're affected by that. And like in a way, a lot of this is actually about creating prediction markets on human behavior, right? Advertising and sort of, the attention economy. You're trying to predict people's behavior as much as possible so that you can figure out like what are they going to buy when, what are they going to be susceptible to, who are they going to vote for if you catch them in this emotional state and talk to them in this voice. But at a certain point, those predictions, like you sort of plateau how well you can predict people unless you start to actually control their behavior. And so that tends to be kind of the end state of a lot of these technologies, or like a lot of these systems as well. So anyway, deshitified systems would be ones that don't just like promise not to do that, but that are built in a way that makes that difficult or impossible, even if the builders later change their minds or like make evil clones of themselves. These things like cannot be done by anyone, including the builders. They also treat centralization as a liability, because if you aren't like profiting from or benefiting from having control, collecting all of the information, having all of this data on people, all of those things are only liabilities if your users are your customers. And so if you can avoid collecting information and still be able to reach like the trust assumptions that you need, if you can avoid being a single point of failure and have systems that are more resilient, unless you have a reason to want to be at the center of everything, it only creates more risk for you and your users. So this is a pretty important point for a lot of these technologies also, being more resilient by being more distributed and having more people empowered to like create and run them themselves, whether that's being open source or peer-to-peer or just letting people control their own information. And finally, most importantly, and kind of summing up everything I just said, these guys are aiming to create value that even if they changed their minds later, they could not take back. So they can stop building it. They can build something else instead. They can go work for Google. But the things that they're putting out into the world right now are things that they can't take back, even if they wanted to. Which I also want to just recognize what, not altruistic, but like forward-thinking commitment that is on the part of all of these builders. Because it is not the quickest road to a lot of money, but it is, I hope, the straightest road to like using technology to improve people's lives, like for real and for good. So we're going to talk about privacy a little bit because this is a major theme. It is not the only theme, but a lot of these builders are thinking about privacy. But I want to like complicate that a little bit because we tend to think about privacy in terms of like binaries or extremes. And a lot of the technologies that we have push us toward one end or like one extreme or the other. So, Facebook, Twitter, Google, all of the sort of social media, a lot of the like extremely online tech pushes us into like the public sphere in a very serious way. And then a lot of privacy tech is this like very adversarial mindset, very defensive, hide everything from everyone. And in fact, that is just not how we work if we are just living our lives like naturally, organically, interacting with different contexts, different people, groups of different sizes, like rooms of different sizes, knowing whether there's a camera pointed at us or a microphone on us, or if we're just having a private conversation. Most of life happens in between these two extremes. So although there are a lot of people working on privacy, and that's super important, like the ability to have this total like dark, secret, like uninvadable space is an absolutely necessary predecessor of all of this other stuff. You can't really have choices unless you have the choice of extremes. But most of what we want to do is actually moving through this sort of middle part of the spectrum and just like being able to make real choices based on like accurate information about the kinds of spaces that we're in, the kinds of people that we're interacting with, the like level of familiarity, the level of trust, and being able to establish the level of trust that we need for a given context, not more, not less, but like just knowing where we are kind of within digital space, which is very easy to do in a physical room. I can see all of your little faces. I can tell who's looking at me. But in digital spaces, it's often a lot less clear. So a lot of this stuff is also about just like letting people position themselves in digital space in a way that gives them a lot more like agency and choice. So just quickly, a few of the techniques that people are working on. You'll hear about a lot of this stuff from some of the presenters coming up next. Cryptography, maybe the most interesting to the people in this room, from zero knowledge to MPC to FHE to like clever ways of sharing secrets among a peer-to-peer network. And then some other things that, in my opinion, anybody who's working really deep in cryptography should be thinking about also, because cryptography alone doesn't get you where you probably want to go, unless all you want to do is like do math in a cave all day. You need to think about the context, both like socially and technically, of how that stuff is going to actually become like full usable products or tools or technologies. So peer-to-peer is another thing that a lot of people are thinking about, whether that's like actually connecting machines so that they're talking directly to each other. We're going to have Clan talk about that in a little bit. Or peer-to-peer in the sense of like person-to-person, being able to interact in a way that involves only the two of you, or only who's sort of invited into the interaction. And also like backing up each other's information without having to rely on a cloud and without having to sort of trust, basically to place trust in someone that you do not actually, in fact, trust at all. And finally, UX, like thinking about how people actually experience technology. How does it feel? What does it look like? How does it help you do things that you want to do? Does it help you connect with other people? Does it like let you in and let you do what you want to do with it? Is it flexible enough that you can move in the way that's natural to you and not on some path that somebody else has sort of dictated for you? And can you make choices and be aware of the choices that you're making within like the environment of whatever technology? Again, there's a really wide range of stuff being worked on here, but yeah, that's just kind of an overview of some of the like technical approaches that people are thinking about. So that's kind of my spiel about the residency. I just want to call out, we have a final demo night next Thursday from 8 to 10 p.m. at Red Dog Gallery, which is the other side of Ping River. We all just came from there. It's not that far, I promise. On the second floor, and anybody's welcome. It'll be kind of a mix of some more formal like presentations and demos, and then hanging out for a while so you can just quiz the developers and presenters about whatever you're curious about with their work. So that's all. Any questions? Oh, also, I'm Althea, and, and I work with PSE, Privacy and Scaling Explorations, which is an Ethereum Foundation team that works on a lot of cryptography stuff. And they, like, this is not a PSE residency, but they've been very supportive of me working on it, of a number of PSE people attending it. So thanks to PSE for that, as well as the Edge City organizers who just like gave us this space, and all the people who have kind of showed up and participated and invited us out for field trips. So thank you. I don't know who's up next, though. It might be. Okay. I don't know. Ayla has the schedule. Just go for it.
Nice.
Oh, sorry. Yeah, this should be on him. Put that on yourself somewhere. That's probably good. Maybe see there. It needs to be closer.
Is this working? Oh, it's filming. Okay, we're going to get started with the first talk. So, hi everyone, I'm Vivek. I'm part of a team called Cursive. I'm representing a little bunch of us. We're all at Edge City. We're all going to be at DevCon, so you can get to meet the whole team there. Today I'm going to be talking about our work in building cryptographic apps for human connection. So I'm going to start with a little bit of a motivation, both on like a technical and social level. What sorts of tools and how we're using cryptography for this, and also just to look into the future for the sorts of features and other things that we're excited about building. So yeah, let's first answer this first question, like why does our team think that cryptography can help with human connection? And I think in general, we like to break human connection into like two different problems. There's one of discoverability, and there's one of like deepening your connection. The current state of discoverability is that you're basically at the whim of different AI algorithms and advertising markets who, first off, own all of your personal data. But then also the objectives here are generally very aligned, or the incentives are very unaligned, in that what they want from you is to maximize the amount of time you're spending there, the amount of money you're spending, whereas like, you often come to these social media apps for like connection and getting to talk to your friends. Cryptography improves this in that with stuff like signatures and zero-knowledge proofs, we get to have full ownership over our data and selectively reveal it. And using tools like MPC and FHE, we get both like controllable, programmable, and also safe interfaces to be able to learn more about different people in your social graph and in your life. For depth of connection, the present is that there's basically no verifiability on data in the internet. You basically just trust platforms, and as a result, there's like this huge wave of bots, and like it's difficult to know like on a dating app if someone is like real or fake. And the other thing that's, in addition to the no verifiability, like everything we have is currently like public. We basically operate in this sort of billboard model where like you put up a public persona of yourself, and in many ways, you're not sharing your truest self. You're sharing a version of yourself that you think people will resonate with. Cryptography fixes this in a bunch of ways. Like again, with signatures and ZK proofs, you get this verifiability across every single facet of the web. And because you can actually privately custody your own data, there's at least the hope that we can express our truer selves more completely. And we can use, again, these tools like MPC and this tool called private set intersection, I'll explain, to discover common and complementary traits. I also kind of want to answer the question of like timing, or like why do we think like now is a good time to do these things? And yeah, again, there's like a technical and like a social trend. On the technical side, I think in general, being able to do cryptography on a consumer level is rapidly improving. Major parts of the tech stack that I'm going to talk to you about didn't exist. Oh, sorry, this is from a previous conference, but didn't exist like even 6 months ago. And like the apps that we have built have actually motivated a bunch of R&D, both internally and externally, to sort of like expedite this stuff. And it's only getting faster and faster. Another really big trend is that more and more Web 2 data is portable and verifiable using tools like ZK Email, ZK TLS, or rather like MPTLS. You can basically start to reclaim a lot of different stuff about yourself. And also like tooling across both ZK, MPC, FHE for consumer devices is like improving rapidly, both in terms of like developer experience and also performance. So there's a lot of really good trends that are making it way, way, way easier to do this sort of stuff. And the other thing which relates to the previous points is that like in many ways, a lot of the sort of like social media apps or apps built around connection are really about your attention. They're like one really interesting kind of like anecdote here is this one like shitposter on Twitter named Nikita basically shared this post that if you now go to Facebook's marketing material in the App Store, there's actually no mention of friends. The entire thing is around like sharing content, like scrolling on feeds, using like Instagram Reels. The entire focus of these apps is on the algorithm because that is what makes them money. They actually do not benefit from you like having deep connections, learning stuff about your friends. And so I think there is a demand for this sort of stuff in that like none of the existing platforms are incentivized to provide it for us. Okay, so now for the technical portion of the talk, which is how are we using cryptography to do this? I'm going to go through both a bunch of past experiences that Cursive has built, as well as some stuff that's upcoming. And we're going to start with ZK proofs, which I understand is like one of the main focuses of Invisible Garden, so hopefully this will be of interest for app builders. I would summarize ZK proofs as enabling both verifiable data import and access control, where you can sort of gate information based on certain criteria. And I'm going to go through some apps that we've built for this. So at DevConnect, we built this experience called Jobmoji, which essentially we gave different like event organizers and people their own NFC cards, not like this, like a full NFC card, where if you tapped these cards, you would receive a baby Jub signature, which is like a ZK-friendly kind of proof of actually having met them in person. And then what we did was we sort of gated different in-person events based on like verifiably meeting these organizers in person. And sort of like this alternative to this model of like a big invite list, where instead if you just like know the folks doing a thing, you get access to the event, which was an interesting experience. But this alone, I think, is not enough to build a full experience around. One thing we did at a recent ZK conference, actually like 8 months ago, was we built something called ZK11 Folded. So essentially the idea here is that as you go through the event, you have these different NFC cards corresponding to meeting people, going to talks. And we took Nova folding proofs to essentially do like a Spotify Wrapped style experience, where you'd take all the different signatures you'd collected over the course of the event, and you'd summarize them, or you'd fold them into a single proof. And this, you could post on Twitter, present in different places, and it would basically be this like summary of everything you've done. And it was this experiment into like, can we use folding to essentially, like summarize a bunch of different data? And ultimately, at that point, it wasn't performant enough. We were using just like vanilla Nova. I think there's been some improvements recently, but it still doesn't feel like the best fit for consumer-facing applications. And then another ZK thing we did was at the Signature Singularity residency, which was a residency funded by PSE. We built this experience called Backpocket Travel, where essentially you could use ZK email to import both like events that you'd gone to in the past, events that you were planning to go through in the future, through like tickets from like Eventbrite and Luma. And we'd also import, actually, instead of tapping people, you could basically import a social graph from your email, because you can import calendar events, you can import payment notifications, and this actually forms a very personal and professional social graph of your life. And so once we had this, we were able to build different like ZK proofs, NPC experiences on top of this. And yeah, it's a very smooth flow, and you get access to a lot of interesting data. Some reflections on these apps is that, at least in the team's opinion, I think if you're trying to build consumer apps with ZK, it's not the most expressive tool. That doesn't mean it's not powerful. It's just like, my personal take on it is that it mostly provides privacy-preserving and verifiable access control. You can prove that someone has met some sort of criteria or has like, participated in a community sufficiently deep enough to then give them access to something, whether it be a smart contract, whether it be like access to an event, a ticket, a discount. And I think there's still a big space of things to build there. But if you're considering building stuff in this domain, I would urge you guys to ask, like, how much is the privacy preservation important? Because that's what ZK provides. You can get verifiable access control from just signatures. And in many ways, if you're trying to build like a loyalty engagement experience, privacy isn't actually very important. You're totally fine with like Taylor Swift knowing like, I went to these 7 concerts, can I get a discount on this? Like, you don't need to be private from Taylor Swift. So that's one sort of overall reflection. And also, in the specific lens that we pursue of human connection, I think actually ZK is best for coordinating with people you don't trust. ZK is all about revealing the minimum amount of information possible. You're selectively revealing things about yourself. And as a result, it doesn't feel like a great fit for this general theme of human connection. But there's still lots of amazing like blockchain and other use cases. This is very focused on like consumer apps and within our own lens of human connection. OK, so the second tool that we've put a lot of time into is a tool called multi-party FHE, or threshold FHE, which is basically this marriage of MPC techniques and fully homomorphic encryption techniques. And I'll explain how that works, but the overall affordance of this is kind of twofold. One is that multi-party FHE provides for like generally lower liveness than other MPC schemes. Like for stuff like secret sharing based MPC, there's lots of back and forth communication that parties have to do, which makes it difficult to build consumer apps because people like put their phones away. And so the computation stops. And the other really nice thing is about multi-party FHE is that you can actually delegate the compute to an untrusted server in a way that still protects privacy. The overall setup for multi-party FHE proceeds in 3 phases. And this is the sort of like interactive mode. Essentially, there's an initial phase where a set of parties, in this case it's a 2PC, but you can expand this to as many parties as you want. They do an initial MPC to generate a collective public key. This collective public key is generated in such a way that no one knows the corresponding secret key. It's sort of like generated together. And so all the parties can feel comfortable encrypting their data to this collective public key. And they can be sure that no one's going to be able to decrypt it, because you need to know the corresponding secret key. Once you have this collective public key, you can then basically take all the FHE encrypted data and then do whatever operation you want. This is like kind of a private set intersection, basically. But you can do anything with FHE. And at the end, there's a final MPC to basically take this encrypted computation and then decrypt it. So all the parties need to come back together to basically generate like partial decryptions, at which point you can see the result of the computation. For this, we built basically this feature called private set intersection, which basically enables 2 parties to take sets of information about themselves, whether it be contacts, interests, things you've done in the past, and then basically find the intersection of these 2 sets without revealing anything else. And we built this using this interactive multi-party FHE. Also, I will share code links and all that sort of stuff afterwards. I don't have QR codes, that's my bad. But yeah, it actually turns out to be a very efficient way of doing it. But the problem with interactive FHE is that even though there's less rounds than there are in other types of MPC, there still is a lot of back and forth because you have this like initial MPC to generate the collective key, and you have a second MPC at the end to decrypt. And so this motivated research by a good collaborator of ours named Gauss Labs, Janmajaya and JP, if you're familiar with them, to basically explore a version of this where you could cut out this first initial phase of the like this initial MPC. And the way this proceeds is that Alice and Bob, or in this case, you can expand to as many parties as you want, but we're keeping it simple. Alice and Bob both upload their public keys to a server, and the server is able to actually generate the shared key itself. So Alice and Bob and whatever other parties do not need to come together to do this initial MPC. So this saves this first round of interaction. At that point, what the server can do is an FHE operation called key switching, which is essentially you take your encrypted data encrypted under key A, and you key switch it to another key under like key B, without the server learning any information. And it key switches it to the shared key, which then enables the server to do whatever computation. At the end of the process, Alice and Bob come together, they do an MPC, and they can decrypt this result. So you still have this final MPC, which is like unideal, but we at least got to cut off like one whole round. And what we were able to build with this was an activation at, oh, I don't have that picture, sorry. An activation of frontiers where essentially two different parties could post kind of in a hiring flow, where one candidate would post like a job profile and their interests and what they were looking for. And a candidate might want privacy over this sort of thing in case like you're currently employed somewhere and you're trying to find out like, hey, what else is out there for me without posting on LinkedIn or something. And then a recruiter can post both like public profiles and also private profiles. And upon meeting, we basically run this computation in the background for them on if there was overlap on like their interests, their salary requirements, stuff that you want to keep private. And if there actually wasn't overlap, then they get notified and they get to have a conversation. And so it's this way of basically enabling like safe and efficient coordination between these parties that may not want to post this stuff on a public, like LinkedIn or something, or just generally like might not find each other otherwise. So some reflections on this scheme. Even though we can actually get this to 4 rounds of interaction, it's still like unideal in that like basically in this flow before, if Alice puts her phone away and the server is computing some computation and sends it back to Alice, then Bob is blocked on getting any sort of result of this computation until Alice takes her phone out again. And especially in like kind of an in-person flow, it's unideal to like require someone to come back to their app, and basically do this partial decryption and send it to Bob. And so ideally, we want to have just like one round. Alice just sends some information to Bob, and Bob just like does the computation. And then the other big problem, at least in the current state of things, is that the uploaded public keys involved in this setup are enormous. We actually ran the Frontiers experience at like a really low bits of security, at 64 bits of security, which enabled us to get 15 megabyte sized keys. Because if you run it at the full 128 bits of security, the key size is like 100 megabytes, which is like completely untenable for like a consumer to upload on like normal Wi-Fi. And so I think there's active research in trying to reduce this, but like for right now, I think is mostly a good fit for like server-based applications. Okay, this takes us to our final tool, which is actually in-house research led by myself and done within Cursive and a bunch of PSE teams called Trinity. And I think the way I describe it is that it's like basically nearly optimal UX and DevX for building at least consumer 2PC, and we're hoping to extend it to more and more parties. Trinity is a combination of 3 different schemes, which is why it's named as such. The first is garbled circuits, basically just vanilla garbled circuits from like Yao. The second is this tool called KZG witness encryption, which is sounds exotic. It's actually an incredibly simple and elegant technique, but it's very new. It's from 2024 from some researchers in academia and the Ethereum Foundation. And finally, good old Plonk, or any sort of like KZG-based ZK snark, except for Groth16. Groth16 doesn't work, because Groth16 is weird. But Plonk and other stuff works totally fine. And the 2 main affordances of Trinity are, the first thing is that it requires 1 round of data transfer to be able to do some sort of 2-party computation. This includes like one round of basically like pre-processing. Like I'll explain it in more detail, but essentially Bob needs to send Alice like a KZG commitment of all of Bob's data. But that one setup phase can then be used for many, many, many 2PCs. So amortize is basically like you have 1 round of interaction where Alice basically can just send a blob of information to Bob, and then Bob can do some sort of like 2PC on that data across their 2 private data. The other really nice thing about Trinity, which also in collaborating with some folks at UCLA who do MPC research is a very unique affordance of the scheme, is that you basically have verifiability on all of the inputs into this 2PC. You can basically prove various properties of it, that it was like valid, it was like a ZK email, ZK TLS proof, or it was like from some signature. And this is a major step on other 2PC schemes because generally verifiability is pursued as doing it inside of the garbled circuit. So you're like verifying an RSA signature, you're doing all this stuff like inside of the circuit. But instead, you can basically offload this to much more efficient ZK protocols like Plonk and other like amazing tooling that's come out. I'm going to go through a very high-level description of it. Please come talk to me afterwards if you want to dive in deeper. I would be happy to discuss. And we should have a code implementation in like a few days. I'm like working on it. It's taking a while. But so here's what a general garbled circuit looks like. You have Alice and Bob. And Alice, essentially, the first thing that she does is she basically sends a garbled version of this circuit, as well as a garbled version of her own inputs. Garbling here you can kind of think of as like kind of, not obfuscating, but like hiding the exact kind of like inputs of Alice herself, as well as kind of the structure of the function. And the thing is, this isn't enough. Bob needs to also know his own garbled inputs into the circuit for him to be able to like compute it. And so usually how this proceeds is by another cryptographic tool called an oblivious transfer. And the oblivious transfer proceeds in basically 3 different rounds, at least classically. And this, you know, in our setting, we really do not want to have lots of rounds of back and forth, because then Alice takes out her phone, does a thing, Bob takes out his phone, does a thing. Like, you kind of like get blocked on each other, and it takes a while for this computation to proceed. So ideally, we want to get rid of this OT. And coming to the rescue is this new tool called KZG witness encryption. The overall API of KZG witness encryption, I'm going to assume familiarity of KZG. I apologize if it's confusing, please come talk to me. But essentially, you take a dictionary of sort of certain indices and certain values, and you commit to it using KZG. And the API of this is such that, as an encryptor, I can take someone else's KZG commitment, and I can encrypt certain data to a valid opening at a specific point. So if someone can produce an opening at a point, let's say like I comma d of I, then someone will be able to basically like decrypt this encryption. But if they're not able to, then they won't be able to decrypt. It's an extremely beautiful paper. I would like highly recommend digging into it, even if you don't have, if you have like base familiarity with KZG, you'll be able to figure it out. And the tool that this provides is something called laconic oblivious transfer, where essentially what you have someone do is, like in this case, Bob, basically commits to all of their different inputs in a KZG commitment. You have different bits like 0 and 1 at all your different points on your commitment. And then what Alice can do is that she can witness encrypt the 2 input wires that Bob might want to choose between to this KZG commitment. And due to the really nice properties of it, Bob is only going to be able to decrypt like the one that corresponds to his own inputs. That's a bunch of like cryptographic mumbo jumbo. The overall upshot of this is that basically Alice just needs to send one message to Bob for this laconic oblivious transfer, and then Bob is good to go. Bob can decrypt his own input wires, and now you don't have this sort of like back and forth communication that sort of makes it difficult to build MPC apps. The final stage of this is Plonk, and Plonk plugs into this super beautifully, where you can basically have like, you know, in your general Plonk setup where you have like columns corresponding to different inputs, you can have your garbled circuit input be the first column of your Plonk proof. Like it's basically some different like, you know, bits. And then the other columns of your Plonk proof can essentially encode like a ZK email proof, a ZK TLS proof. And what this provides you is basically you can have like provable attributes about your KZG commitment so that you know, like, for example, if a bit corresponds to like, oh, I went to this college, or I have a bachelor's degree, like it's a 0 or 1, you can actually prove that that's correct based on some other like information you're including in this circuit, which is much more efficient than doing this like inside of the MPC, which is the traditional way of doing it. And so maybe like the overall flow here, the overall API of Trinity is as follows. Basically, what you can do is Bob can define hidden filters, F, and some hidden information, M, like just some message that he wants to send to Alice. And what Trinity enables is that basically you can compute this function, F, like his filter function, on some criteria from Alice, C, which outputs like a true or false. Does Alice satisfy this criteria or not? Times whatever hidden information you want to give. And so basically you can basically like send an encrypted email to somebody, and only if they actually match whatever hidden criteria you have can they actually decrypt this information. And so maybe like one example of this is like you want to throw like an exclusive party, and you only want it, the only people you want to be invited to are people that satisfy certain like niche criteria of yours. You can just put this out into the world, and then only the people who actually do satisfy this criteria, which is also verified from the various ZK techniques will be able to see this information. And the general upshot of this is that we think this will allow basically more efficient sort of distribution of information to folks that it's most relevant to. Okay, and yeah, I just want to talk about some very high-level features, step away from all the cryptography to inspire some creativity. And all of this will be available in a DevCon experience that we'll be shipping. If you guys are attending DevCon, we'll have a booth right near the entrance. You can pick up a little NFC chip, and you can sort of try out all this stuff. So 3 different features. The first is this idea of super connectors. So essentially, as you sort of like, in the app experience, you can basically tap different folks and grow your social graph. And as you do that, you'll basically learn different information about them through things like private set intersections and other queries. And what you can do is that because you now know this information about folks, you can basically serve as this like connector of folks in your social graph, where you can like refer to people to like meet each other based on you knowing like, oh, you guys have a lot in common, or you have a lot of like complementary interests. And the idea here being like, this is a way to empower humans to perform this connection instead of like defaulting to some algorithm or some AI like kind of overlord to do this for us. Another idea is this idea of narrowcasting, which is kind of the opposite of broadcasting. And this builds directly off of like Trinity's affordances. The idea here is, again, like you can basically choose a specific set of criteria for people that you want to receive some information. Instead of posting on like a big public feed or like making like a bespoke group chat for something, you can just choose your criteria and then send it off. And only those people will be able to see it. And finally, there's this idea that we're calling digital pheromones, which like for biological context, a pheromone is like this chemical that different animals produce to essentially like enable members of the same species to coordinate in some sort of way. And we think that cryptography can provide actually a very similar affordance, where all of us can basically be releasing these sort of like lightweight, undetectable, privacy-preserving signals into the world. And then we can just have sort of like MPC-style coordination on this to let people discover like synergistic, complementary relationships, just new connections that they would not have otherwise gotten. So Cursive itself is a team that I'm a part of. I lead cryptography on Cursive, and it's a research and design lab building this sort of stuff, cryptography for human connection. We'll be at DevCon. I'll be around for a few hours here, so come talk to me if you're interested. And huge shout out to Privacy and Scaling Explorations. We're a grant-funded team, and we work with some full-time folks on the team as well. Without their support, this would not have been possible to explore and dive into, as well as like the numerous researchers within the ecosystem that we've been able to very like positive sum collaborate with. So big shout out to them. And that's me. Thank you. I can take questions, but also that was a lot to throw at you guys. So if you want to digest, that's fine too.
Is current PSI protocol interactive?
So we've actually implemented a new PSI protocol because the other one is really slow, which is super simple. Essentially, we both create a shared secret. We hash all of our data salted with the shared secret. And then a server can see, OK, you two have these hashes that are the same, and sends it to both of us.
Okay.
But introduces this new trust assumption that if the user colludes with the server, then they can read your data, basically. But it's much faster, and we're fine with that assumption because we're running the data.
It's still interactive.
It is still a two-step thing. It's an open problem if we can do this in one step, actually.
Who creates salt? Is it generated on server?
So there's two models. One is that we create a shared secret together. Like if we're doing a PSI between us,
Yes.
I get your public key,
Yeah.
generate a shared secret, and that's a salt. The other version that we've built out is like, you can either do this in like a trusted execution environment or an MPC, generate a salt, and then salt the data. Yeah. But unfortunately, there's still some rounds of interaction.
Is it possible to do non-interactive PSI as well?
That is an open problem that I am thinking very, very hard about. I would love to jam on that.
You just open your contacts and you do PSI like without
With-
requiring their interaction.
Exactly. I think it's doable.
With FHE, bro.
With FHE, it's definitely doable. It's just stupidly expensive. So something cheaper would be great.
What primitives are you using for the Harvard circuits? Like, which primitives are being used? So how do we use the Harvard circuits?
Right. I'm using MPZ, which is tooling from PSE. It's tooling that was abstracted out of TLS Notary. And there's also some amazing TypeScript tooling from a developer named Andrew Morris. It's called summon-ts. That essentially enables you to write circuits in TypeScript, which then compiles into Boolean circuits, which then enables you to do a lot of other stuff. So that's my main stack right now.
Like, how do the garbled, like, garbling works? So, like, if I have some data,
Yep.
how will I garble it?
Like theoretically or like like in code?
Like, whatever you can.
Okay, sounds good. In code, there's basically like WASM compiled Rust that you can just run in your browser. It'll just handle the garbling for you. At a high level, you're basically just assigning like a random label for each input. And you're essentially doing this across the whole circuit such that like as you proceed through the circuit, you can only kind of go through like one path, kind of. I would recommend reading the Vitalik blog post on garbled circuits. It's very good. But yeah, that's the setup.
I think it depends who requires the PSI, for example.
Sorry, go ahead.
Who starts who starts the PSI interaction?
Yeah.
It's like that's like what how to say define who will be governor, who will be evaluator.
Yeah. Cool. Thank you, guys.